What's up, everyone? This is LeetCode 101, Symmetric Tree. So we are given the root of a binary tree, and we have to check if it's symmetric, meaning we have to check whether it's a mirror of itself, right? I.e. symmetric around its center. So really, you just have to pay attention to what the properties of a tree that is symmetric are, right? For example, example 1, this is symmetric, and our output should be Boolean, right? So if it's symmetric, return true. If it's not symmetric, return false. So we know this tree is symmetric, right? They gave us a nice example. So let's pay attention to the properties, okay? So let's go left and let's also go right, okay? So when we're at this 2 and we go left, there's a 3. But when we're at this 2 and we go left, that's not a 3, that's a 4, right? If we go right, it's a 3 though, right? Now when we're at this 2 and we go right, there's a 4. So when we're at this 2 and we go left, there's a 4, right? So you really want to go in different directions for each side, right? If you go left on the left subtree, you want to go right on the right subtree. Does that make sense? Okay. Because you need to imagine putting a mirror here, right? If you mirror this side, on the other side, this 3 would be obviously here, just like it is, right? Like imagine literally holding a mirror up and mirroring this side, right? What you would see is the 3 on this side, okay? So there's really a couple properties, right? When you go left on the left subtree, you need to go right on the right subtree. When you go right on a particular subtree, for example, on this left subtree, when you go right, you need to go left on the other subtree. Not just that, right? Meaning if you go left on one subtree, you need to go right on the other. Likewise, you need to go right. If you go right on one subtree, you need to go left on the other subtree. Not just that, but they need to have the same values, right? That's what makes it symmetric, those 3 properties, okay? Now, there can be situations where you encounter a null node, right? For example, let's go to this 2 and this 2. When we go left on this left subtree, we should go right on this right subtree. Well, we have 3 and a null, right? So this is not symmetric. Likewise, when we go right here, we have a 3, but when we go left here, we have a null, right? So if we have null, is fine. If we have a null node, we encounter a null node, that's fine as long as we encounter a null node when we go in the proper direction for the other subtree, right? Meaning, right, if we're at this 3 and we go left, right? Then at this 3 we should go right. But they're null in both cases, so that's fine, right? But here, for example, we're at this 2 and we go left. We have a null, but at this 3, we go right and we have a 3. So when one of them is null and the other is not, that means we have a problem. But if they're both null, it's okay. Does that make sense? Okay. So let's just make a function, right, to help us with this. Okay. So we're going to say Boolean DFS, right? We're going to have a left node and a right node. And what did we say, right? If the left is null and the right is null, right? That's okay. So we return true. However, if left is null or right is null, we have a problem. And of course, we handle if they're both null up here. So down here, we would only enter this in a case where left is null but right is not, or where right is null but left is not, okay? So in this case, we want to return false because they either both need to be null or neither of them can be null, right? You can't have one be null and the other not. At that point, the tree is not symmetric, right? Okay. So outside of those cases, right, we need to handle a few conditions. Okay. So let's see. When we're at this left subtree, right, if we go left, then on the right subtree, we should go right. Okay. Also, if we're at this left subtree, or a left node, when we go right, then on the right node, we should go left. Okay. And so basically, this is just the symmetric properties, right, that we talked about earlier, right? If you go left on one side, you need to go right on the other. Likewise, if you go right on one side, you need to go left on the other. right? But there's also a third property that we talked about, which is what? The left value needs to be equal to the right value, right? Boom. The 3 symmetric properties that we care about is that, okay? Then down here, we need to actually call this. We're given the root node, so we're just basically going to move to the left and to the right. So we're going to say root.left, root.right. Okay, just like that. Of course, you want to actually return something, otherwise you're not going to return false or true or false. So yeah. Whoops. Did you mean val? Oh, I put 2 L's. My mistake. So yeah, really the 3 symmetric properties we care about. So just pay attention to these illustrations. They really do help. In an interview, you might not get these though, and then this problem might be a little bit harder. But in those cases like that, just ask questions, right? Or draw it out if they allow you. If that's even allowed. I mean, if you're on like a certain website like LeetCode and you're given this problem without illustrations, it might be a little bit hard to draw it out, but always ask questions if you're not given illustrations like this. I think this problem is made easier just by this, right? By giving you these illustrations. If these weren't given to you, I think this problem would be a little bit more tricky to intuitively come up with what the symmetric properties are. You might have to actually think a little bit. But yeah. Anyways, I hope this helped, and I'll see you in the next one.